Welcome to my tutorial on how to make Pong for the Playdate. Whether you're new to game development, new to Playdate, don't even have a Playdate, or just enjoy watching people make games for the Playdate, this video is for you. I'll be taking you step by step on how to make this game for the Playdate, and I promise if you follow along on this video, not only will you have a fun Pong game you can play on your computer or Playdate, but you'll have a good understanding of how game development works on the Playdate, and will be able to take that knowledge to improve this game and make new ones. I will be going over a lot in this video, so I made checkpoints to make it easier for you to follow along if you need to come back. I will also be using a lot of resources, so anything I use will be linked in the description. If you enjoy this video, all I ask is if you leave a like so we can help other game developers find it, and leave a comment about what game you're excited about making. You can also support this channel more by becoming a member or donating by clicking the tip button below the video. I'm super excited to show you game development for the Playdate, so let's get started. To get started, we need to set up our Playdate dev environment. To do this, we're first going to need a code editor. I will be using VS Code, which you can get by going to code.visualstudio.com and downloading for Windows. Next, we're going to need to get the Playdate SDK. We can do this by going to play.date, go up to the Dev tab. We can check this little box that says I agree to the Playdate SDK license, which I definitely recommend you read, and then you can download Playdate SDK. We'll be using 2.6.2 for Windows. We can wait for that to download at the top right. Now that it's downloaded, we can go ahead and open it up and say yes. And then we want to install our Playdate SDK, and I recommend you do it in the default location. It'll make our next step easier. So we can just hit install. We can wait for this to install. It doesn't take that long, at least not on my computer. And then we can hit finish. Great. Now what we want to do is we want to get our template. Now there is a great YouTuber out there called SquidGodDev. I will put a link to his channel, a link to his videos, as well as a link to his template in the description. And he's gone ahead and made a template for us that's going to make getting started with Playdate development even easier. He also has his own tutorial on getting started with the Playdate development, which I'm pretty much following in this video for Windows. But if you are on Mac or Linux, you can definitely check out his video. I will put a link in the description, and definitely set up your environment for those platforms. Then come back to this video and then we'll continue. But for Windows, I'll show you how it's done. So on his GitHub page, we're going to scroll down to the section right here that talks about environment, and we're going to copy this code. And then we can go ahead and hit our Windows key and type in PowerShell and open this up. And then we can actually paste this command into PowerShell. This command essentially just sets up our environment variables, which gives us a direct path to the Playdate SDK. This will come in handy later with VS Code so that we can build our game inside of VS Code without having to run a lot of commands ourselves. It gives us the ability to do that through his template. So we can hit enter, and that's going to take a moment, and then we're done. So we can actually close out of that. That's all you have to do for that. Very easy setup on Windows. Again, definitely check out how to do it on Linux and Mac with his video. Then we can scroll back up to the top, and we can click this little tab, this little box that says code, and then we're going to download the zip. This is going to download a zip of his template, which we'll use. Again, SquidGod, thank you so much. Made it very easy, and I appreciate you. Once downloaded, we can go up here, and then we can open up the folder. Once we open that up, we'll have a folder right here called Playdate Template Main, and it's a zip folder, so we can open it up, and then here is his template. So what we can do is we can right click on our desktop, go to New Folder, and we can call this Playdate Games. And this is where I'll put all of my games. We can then drag this folder into this folder, and then we're good with the zip file. Now that we've done that, we can open this up, and we always want to keep a reference to his template, and instead we want to copy it and make a new one for each game we make. So we can hit Control C, Control V. This is going to give us a copy folder, and then we can hit F2 to rename it, and we're going to call this Pong with a capital P. You can name it whatever you want, but we're making Pong today, so this is going to be called Pong. And then we can go ahead and close out of this. And now we can hit Windows key and type Visual Studio, or just VIS, and open up our Visual Studio code. Once it's open, we can go up to the top and hit File, Open Folder, and we can navigate to our desktop, Playdate Games, and open up Pong and select the folder. Now inside here, there is a README. This is from SquidGod. We can actually delete it. It's just what was on his GitHub page. Move to recycling bin. We can then go into the builds folder and select builds folder.txt. This is where all of our builds will come, and that's what SquidGod is telling us. And we can also delete this file as well. Perfect. Now we've deleted all of that, we can go ahead into our source file, and then in here we'll see a main.lua file. And this is essentially our game, which if none of this makes sense to you, that's completely fine. We'll come back to this later. But first, what we want to do is we want to install some extensions so we can make our game. To do this, we'll head over to this section right here where it says extensions, the little building blocks, and we can type @recommended, and this will give us an option of two extensions. The first one is going to be Lua, which we can click and hit install. Trust the publisher. Always make sure you trust them if you're going to trust them, but we can go ahead and click trust and then install it. This allows us to have more tools when coding in Lua, which is what we'll be using to code our game. Next, we can also do the Playdate debug, and we can install this as well, and this gives us the ability to open a simulator and debug our game, which we need in order to make Playdate games. Again, this all runs in VS Code, which is why it's recommended to use this code editor. Once that's installed, we can go back to our Explorer and go to our main.lua file again. And now you'll actually see there's a little play button at the top right, which we can click, and this is going to build our game. It's opened up right here. We need to hit OK on this regular test your game on Playdate. This is very important. Even if you don't have a Playdate, you can make a game, but you really want to make sure that you test it on an actual Playdate before you release a game, because it may work differently on your computer than the actual system. And odds are you have a really good computer, or at least a much better computer than the Playdate. So just keep that in mind. We can go ahead and drag this over here just so it's a little bit easier to keep track of. And then I like to go up to view and then screen zoom and zoom ×2. And then we can move it over here a little bit and then reposition our windows. Awesome. Now, if we go back into the main.lua file, keep hitting the wrong button, we can close this out. And now here we actually see a game that was created by SquidGod. And if we hit play again on our main.lua, it starts the game. Now you can actually use the crank, which is down here, and we can actually control this. So definitely check out the code and see if any of this stuff makes sense, but if it doesn't, that's completely fine because it will soon. Now we can hit spacebar on the simulator and this will pause our game. And now we can get started with making our own game. So to do this, we're first going to go into the PDX info file, and in here we can update this information. The name is going to be the name of your game, which we can call Pong. The author would be you, so for me it's Spellthorn, and then the description, we can do a simple game of Pong for the Playdate. And this would be your game's description. We also need a bundle ID when making a game, and this is done like a website but backwards. So first it's com dot whatever your alias is, or if you have a website, whatever your website is. For me it's Spellthorn, and then another dot or period, and then the game name, in this case Pong. You always need to make sure that the bundle ID is completely unique, and this is a way of doing it. Everyone should have a different bundle ID, and no one should be repeating them. We also have the version, which we don't need to worry about right now, and then the build number as well. We can talk about that in the future, but you would increase these when you update your game. We can then save that file and then go back into the main.lua file. Now with this, we actually don't need any of this. We can actually hit Control A and backspace to delete everything out and save it, because now we are on our own. All right, now we can get started with our game. Now, when it comes to coding in Lua for the Playdate, there's a lot of things that we need to use, and we can do this by importing a library. And the first library we're going to import is going to be the graphics library, because without the graphics library you cannot do anything on the Playdate. Everything involves using graphics. So to do that, we can type import and then single quote, we'll do core libs core libs, it already pops up /graphics. And then this is essentially importing a library to access the graphics library. Perfect. Now we need to get a reference to Playdate so that we can start using the built-in Playdate functions. I'll write it out and then I'll explain to you what each of them are doing. So we'll do local PD const equals Playdate. So what this is doing, local means that we're creating a local variable, and it's best practice to always to make your variables local if you can, which means only this file has access to it. If you make stuff global, which we will later, it means any file can access it, and depending on what you're trying to do, that's bad, because if there's multiple names, especially if you rename stuff the same, they're going to be all over the place, and you'll probably use the wrong one, or you'll change something you don't want to change. So it's best to make as much as you can local. It's also really good for optimization because it's less everything has to keep track of, but it's very important to make as much as you can local unless you need it global. Next we have PD, which is just short for Playdate, and it makes it easier for us to write it. We'll be writing Playdate out a little bit, so it's easier for us to write that. Const here means that this is constant, which means we are not able to change this information. It's always going to be what we initially set it up as, and if we try to write to it and rewrite it, we're going to get an error, which is great because we don't want to change Playdate, and Playdate is actually the built-in everything, essentially. It's the actual, as you can see here, there's so much that Playdate gives us access to, and we're going to be using that to make our game. So that's how our first variable works. So now we need to add another one, and this is going to be for our graphics. So we'll do local gfx const equals, and then we'll use our first variable to save some time, and then we'll write graphics. And what this does is this gives us access to the Playdate graphics. And if you hit Control and click the word graphics, you can see here all of this stuff that we have, and this file is huge. And if we hit Control graphics again, you'll actually see a breakdown of even all of the stuff that we have that's built in that we can use if we need to, which is really great. So we can close out of that. So now that we have access to our graphics, there's one more thing that we need, and that is going to be the update function. For example, if we save and reload our game, we're going to get an error, update error, no such function update. And if you don't have the Playdate console, you can go up to View, Show Debug Console, or Alt-Y, and then I dragged it down here so I can see it at any time. Sometimes it'll be behind your VS Code, so make sure you look for it and drag it here if you haven't. Cool. So obviously we need an update function. So how do we do that? Well, that's actually built in with the Playdate. So we can do function, and then we can call PD update, and that's our update function. And what the update function does, and if you hover over it, is it tries to call itself 30 times per second, which is essentially our game loop. Anything we put in here is going to be called every 30 times per second, which is how our game works. And we can actually test this by using in our print. So we can type in print, parentheses, and then if we type something in here, we can just write update and save. We'll see update, 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 and you get the idea. This is updating 30 times per second, and we can actually we can actually make a quick local variable here, local counter equals 0, and then we'll do counter plus equals 1. If you don't understand this, that's okay, you will soon. And then we can pass in counter. If we save and reload this, we get 0 through, and it's just continuing to count up and up and up and up. So we don't obviously want that, but that is how you can print stuff to the console, which will become in handy for errors, testing, all of that stuff, which we'll do later in this video. Great. Now what we want to do is we want to create something. Well, what do we want to create? Well, there's a lot of things we can create for our game, but we're going to start with the ball because Pong is nothing without the ball. So we can come over to our source folder, click New File, and we will call this ball.lua. And in here, we can actually start giving the information about our ball. Now, when we're doing this, we're actually going to create a class, which you'll see in a moment. And anytime we use classes or object-oriented code, we need to import another library. And this is going to be import corelibs/object. And this essentially allows us to write object-oriented code, which you'll see what that means in a moment. We're also going to be using the graphics library, so we can import that as well. We pretty much use that all over the place, so you'll get in the habit of importing the graphics library. And then, of course, because we're going to be using the graphics, we need to get a reference to the graphics. Now, in this file, we don't actually type in Playdate, because we don't need to, but we do need a reference to the graphics, so we can just do local gfx equals playdate.graphics. Awesome. So now we can actually create a class for our ball. And in object-oriented code, everything is pretty much just an object. And if you think in the world, anything you look at is an object, and that object has characteristics, whether it's a size or a color or a smell or whatever. And that's pretty much what we're going to do here. We're going to create objects, give those objects all of our informations or functions, however, whatever it needs to exist inside of a class. And then we can reference that class, change that class, use those functions outside of that class, which is really cool. So to do that, we'll type in class, parentheses, and then we need a, we can do double quotes, and then we can type in a name for our class, which for ball is going to be ball with a capital B. And this is our class. We can now pass in information. But when it comes to Playdate, there's actually the ability to extend classes, and we can do that by writing extends, .extends. And what class do we want to extend? Well, there's actually a built-in sprite class, which is going to give us a lot of built-in functions that we can use to make our, in this case, sprite for the ball, function better. That way we don't have to hard code a lot of stuff. So to do that, we need to import another library, which is corelibs/sprites. And now in our extends, we can call gfx.sprite. And if we save this, and just like we did before, we can hit Control on our keyboard and click Sprite, we can see this entire file. But if we hit Control and Sprite again, you can see all these built-in functions that we can use. There's new, there's the update function, the add, which we'll use, the remove, move to. There's so much built-in stuff that we're going to use to make our game, and that's why we extend the graphics sprite. And that's the best thing about classes, is you can make a class that's extended by another class, extended by another class if you need to. And that's really, and they all inherit the previous class, which is really cool. So now that we have our class, we want to be able to create information that our ball needs so that we can start using it. And we can do this by typing in function and then our class name with a capital B, because it's a ball, but capital B, and then we can pass in colon and then call init. And what the colon does, as you can see here, we did .graphics. What the colon does is it passes in self, which we'll see in a moment why we need that. But essentially, we are making a function that has the ability to call self, so that way we can use that information to either define stuff for ourselves, or later we'll make other functions that we need reference to self because we're using the information that our self has. Hopefully that makes sense. If not, like I said earlier, you can ask ChatGPT, copy the code, and say, explain this. Why is there why is there a colon instead of a dot? ChatGPT is your friend. I definitely recommend you use it. So now that we have our init function is called as soon as our file is called, which we'll get to. So this allows us to create variables and set up all of the information our ball needs to have to actually work. And we can actually start off by giving it the most basic one, which is going to be a width and a height. Our ball needs a width, so we can do self.width. Again, this is why we needed access to self, which is why we have the colon. It just does it for us. It passes self in rather than us having to write self here and pass it in. Cool. So self.width is going to be 10. Self.height is going to be equal to 10 as well. So now we have a ball with a set width and a set height, which we can use to actually create our ball. So to create our ball, like physically be able to see our ball, we need to give it an image. And we can do this by calling self.image, and then it's going to be equal to something. And our image, now we're not going to use a real image. We're actually going to create our image using code. And we can do this by doing gfx.image.new, which is essentially a new image. And by default, this function has two options. If I go back, I went a little fast. We can see that there's two options for this function. We can either pass in a path, which would be an actual image file, or we can create it with a width, a height, and a background color. So let's go ahead and do that. Parentheses. We are not going to pass in an actual image. We're going to make one. So we needed to pass in a width and a height. So we can do that by doing self.width, comma, and once you hit comma, it knows that, hey, you're trying to add more parameters here, which means you're trying to use a different part of my function, and then it tells you exactly what you need. So we passed in the width, which was an integer, which is a number. We need a height now, which is also an integer, which is a number. And then we could even pass in our BG color. However, there's a question mark here, which means this is optional. We do not need to pass in a color. If we don't, it's going to choose it. And you can actually see that here. The optional BG color argument is one of the color constants is used in the Playdate graphics.setColor, defaulting to color clear. So we could change the color if we want to, but we don't need to right now. Cool. So we will pass in our width though, and our height. Width and height. Great. Now what this has done is we've created a blank image that is the size 10 and 10, width of 10, height of 10. But that's it. It's just, think of it like a container. It's just a container for our image. Now what we need to do is we need to draw to that container. We need to draw to that image. And we can do that by calling gfx push context, and then we'll pass in our image. So now this is telling our code, I made an image, it's completely blank, there's nothing in it. I'm going to push stuff to it, to the context of that image. And anytime you push context, you want to make sure you pop context, gfx.popContext. So this says, hey, I'm going to start drawing. Hey, I'm going to stop drawing. And then anything you want to draw just needs to be in between those two sections. Well, now we can start drawing to our ball, but how do we draw an image? Well, gfx.draw, and as you can see here, there's a lot of different things that we can draw. Cool, but we don't actually want to draw anything because draw will give us just an outline of it. Maybe we do, depending on what you're making. But for me, I want to fill something. I want to draw it and also fill it. And we can call fill, and then we can actually do a round rect, which is a rectangle. And here you can see there's two different ways. We can do R in radius, or we could do round rect and then pass in an X, a Y, a width, and a height, and then a radius. So let's do that one. You don't actually have to click it, but we need to pass in that information. So, well, you need an X and a Y. So our X and a Y is gonna be 0, 0. When it comes to Playdate development, X and Y 0, 0 is going to be the top left. X400, Y0 is going to be the top right. X0, Y240 is going to be the bottom left. And X400, Y240 is the bottom right. And if you choose any numbers in between there, it's going to end up somewhere in here. Now for our image is a 10 by 10 image. So we want to make sure we start our image at the top left, which is going to be 0, 0. But then once we hit our comma, now it needs a width and a height. So we can do self.width, because we already have that built in, and then self.height. And then we need to pass in a radius, which we can make 10. Now, we can save this, and nothing's going to happen because we're not done yet. We can play the game and we're actually, nothing's going to happen. But what we want to be able to do here is two things. One, we don't want the number 10 here for a radius. This is called a magic number. 0 is a little bit different because you know what 0 is doing, but 10, what is 10? What is 10 doing? I don't know unless I read the fill round rect that this is a radius. Magic numbers are bad, and they're bad for two reasons. One, future you is going to forget what this number is for, what it's doing, why you chose 10, who knows what, why did you do this? And number two, once you hard code a number, you can't easily change that number. So let's say our ball was bigger, we wanted a different radius. Well, if I pass in 10 hard coded, how am I going to change that? I can't. And we want it to be able to change dynamically. We can easily change our width and our height by just changing it, but we can't easily change the 10. So magic numbers are bad. Please try to avoid them. I still struggle with that. Sometimes I use magic numbers, but I'm trying to get better. So if I could start you off by always knowing don't use them, we'll be in a safe spot. So to do this, let's make a radius. Self.radius equals 10, and then we can just pass in the self.radius. And now it's very easy for us to change this number in code. We could always call ball radius 15, 20, whatever, and it will easily change rather than now we have to update all of our code. And let's say you want to do an update later where you add a power up and now you have to go through hundreds of lines of code and change anywhere you started putting random numbers. You're going to hate that. So don't do that. Avoid magic numbers. Cool. Now we've created our image. Let's actually leave a comment here. We can either hit -- or // to get the comments, and we'll do create the balls image. Perfect. And then we can go ahead here and we need to set the image, because right now we've made an image, which is blank. We've push context to that image, so now it actually exists as how we want, but we need to set that image, and there's a built-in way to do that. Self, because we're grabbing ourself, set image, and then we can pass in the self.image that we just made, and then this will save the image to ourself. Perfect. Well, if we save this, we now have an image. We should see it, right? No. Why not? Well, a few reasons. One, we're not adding our game to anything. This is just a file. Our game is not, our ball is not added, but there's a function for that. We can do self, add, and now our ball should be added to our game. All right, well, where is it? Well, we haven't called this yet. We've created it. It's in the file. We have an init function, but we're not calling our ball. We're never using our ball class. And the reason is because we never called it. So what we can do now is we can go to our main.lua, and we need to import our ball, our file, essentially in this case ball. So we can import ball. You don't have to write .lua. If it's a .lua, it assumes it's .lua. So you can save some time and you can just import ball. And now we can make a variable so we can use this. So we can do local ball equals ball. Perfect. And then now we have a ball. And if we save this and reload it, what happened? We made the ball. We've called the ball. Why isn't it showing? Well, we used a sprite. Anytime we use a sprite, we need to make sure that we tell our update function to update the sprite. And we can do this by calling gfx.sprite.update. And what this says is, and we'll even comment it, what this says is call all sprites update function. You see, in order for something to exist, it needs to have an update function, which is why we had to do pd.update, because without it, the game doesn't load. However, we did not call an update function here. So what's an update function? Well, gfx.sprite has an update function already. We didn't call an update function because we're not overriding the default update function. If we were, then yes, we need to call an update, which we will later. But right now, we still need to call the update function just there wasn't one. We're using the default one. So now if we go back to main.lua, this every frame, 30 frames per second, it's going to say we need to call every sprite's update function so that everything loads together. And now if we hit play, we have a ball. Can you see it? It's at the very top left. Why? Well, one, everything's at the top left, 0, 0, because we didn't tell it to move anywhere. We haven't put it anywhere, but we have a ball. So let's go back into our ball.lua and we'll actually move our ball. Let's kind of add more comments here. I'm bad at adding comments. I apologize, but I want to make sure I add them. So we can say add a ball to screen because that's what that's doing. Just to prove it, if we comment out the self.add, our ball disappears because we're not adding it to the screen. And then we can also move our ball with a built-in function, self.move2, and then we can pass in an X and a Y, which will do 200, 120, which is the center. Perfect. There's our ball. And the cool thing is if we change our width and our height, this is why I said it's very important that we use variables, right? Well, there we go. And this is why I explained to you the radius, right? So our radius is 10 because imagine if we hard-coded 10, this is what our ball looks like. Is this a ball? No. Well, now we have the ability to change our radius with the width and the height, and now there's a ball. Cool. So let's go back to 10 because that's way too big of a ball. But here we have our ball. Well, what did we do wrong? Hopefully you know what we did wrong. I only did it for quick testing, but what did I do wrong? What did we do wrong if you copied the code? Magic numbers. That's right. Magic numbers. We don't want magic numbers. Magic numbers are bad because we can't change magic numbers. This move to is now stuck. How do I call a move to? I'd have to call another one. That's not good. So let's make sure that we make variables for our start X and our start Y. And we can actually call it that. Start X equals 200. Self.startY equals 120. And then we can pass in self.startX and self.startY. Start Y. Perfect. Save and reload. Same. But now we could easily move our ball to a different location very easily without finding hundreds of lines of code, layers deep somewhere, right? So we don't want to do that. Perfect. So now that we have our ball to the screen, let's actually make it do something, right? This is boring. This ball's just sitting here. We want it to move. How do we make the ball move? Well, like I said earlier, we have an update function for our class. And now we can actually add to the default update function. So we'll do function ball with a capital B because again, it's linked to our class. We're going to need access to self. So we want to make sure that we do that. And then colon, and now update. Again, it has to be called update because we're overriding the update function. We're adding to the update function, and we can save that. And now what we can do is we can actually get, we can call a different function. And this function, again, built in, self.moveBy, rather than move to moves to a certain location. Move by is going to run every frame and update it to a different location. So we can pass in 1, 1 just for testing magic number. Hopefully you realized that you would need to make a variable for this, hopefully. And then we can hit play. And now our ball moves and it's going to the bottom right. Why? Well, again, earlier, X starts at 0 and goes positive to the right. Y starts at 0 and goes positive down. So an X1 goes to the right and a positive Y goes to down, which if we add them both together, we get down right. If we were to change this to a different number, like -1, well, now we're going to move up. Awesome. Cool. Which is really slow. But again, let's not use magic numbers. We can go ahead and do self.dx, which is direction x is a great way to write this. And we're going to just pass in 4. This is how fast we want it to move on the x. And then we'll do self.dy equals 4 as well. You could always change these, but we'll leave that at that. And then we want to pass in self.dx and self.dy because A, we want to be able to change this, and B, we don't want a magic number. So now if we play this, our ball is going to move a lot faster towards the bottom. And then instead of, if we wanted this to be negative, we can just do a dash or minus sign, whatever you want to call this symbol, next to the self dy, and it'll make it negative. So now it's -4. It's like us writing -4. And we can actually do that here as well, -4, if we wanted to go to the top right. But right now it doesn't matter. We're going to be changing it. So we can do to the bottom right. Awesome. Well, now that we have our ball moving, I don't want him to go off screen because he will go off screen and travel forever. He's still moving into the unknown. So let's make it so that our ball can bounce off the wall like a normal game. How do we do that? Well, we're going to come into our update function. We're going to add a comment, and we'll call this wall collisions. Collisions. Perfect. So how do we check if our ball is at the top or the bottom? Well, we can write an if statement, and we actually get it here, if ... then. We can hit enter. So if, what is if? Well, if our ball's y, so we'll do self.y, and self.y we never made. How do we have a self.y? That's built into the GFX sprite. So we can reference our y, which is going to be the center of our ball. That confused me for a while. Sometimes y's are the top left, 0, 0, but ours is always going to be the center of your object. So self.y is less than or equal to the top of our screen, right? Our y is our vertical. So we're going to say if self.y is less than or equal to 0, which is the very top of our game, then we're going to do something. What are we going to do? Well, it's actually very simple. I kind of already showed you. We just want to take self.dy, which is the direction we're going on our y, and it's going to be equal to the opposite, which is negative self.dy. Perfect. So self.dy is going to be equal to itself negative, the opposite. And if we save and reload this, we're never going to test the code because I am going down. So let's switch it to -4 for testing. And then if we go up, boink. Did you see that? Let's go back again. Oh, boink. It doesn't make that noise, but that's what it sounds like. Boink. Right? Our ball is bouncing off the wall. Literally. Literally, it's bouncing off the wall. That's awesome. So how do we make it bounce off the bottom wall? Well, we can change that back to 4. And we could do another if statement here. If.self.y is greater than or equal to 240, which is the very bottom. And then we can just copy this and paste this. And if we save and reload, boink, now it bounces off the bottom. But what do we do here? We did 2 things wrong here. One, magic numbers. We'll come back to that. But what did I do? Well, I made my code messy. I'm doing an if statement here, and I'm doing an if statement here. But I'm doing the same thing. I'm passing the same information. So why would I write this twice? And that's a good rule of thumb with coding. If you're writing something over and over again, there's probably an easier way. It's a good way to remember. Hey, I'm copying, pasting a lot of this code over and over again. There's probably an easier way. And we can actually do that here. So instead of just doing self.y is less than or equal to 0, we could also check if self.y is greater than or equal to 240. By writing or. Self.y is less than or equal to 0 or self.y is greater than or equal to 240. And now we don't need this at all. We can delete it. I hit Alt-Shift-F there. I'm sorry, Alt-Shift-F. Kind of like refactors your code. I don't know if I've been doing that lately a lot, but I do use that. So if we play the game, it bounces off the bottom. And now we only have 2 lines of code to do that. And it still works. And just to prove it still works, we'll do -4. Perfect. And it'll bounce off the top. Awesome. Well, for right now, this is how Pong works. It only bounces off the top and the bottom. But to make it so we can actually see more stuff, because it'll be a while before we handle the sides, we'll type in temporary X wall collisions. We normally won't have X wall collisions, but for right now we will. So if enter, self.x, which is our X, is less than or equal to 0, or self.x is greater than or equal to 0, 400, the width of our screen, then what do we want to do? Well, we can do self.x equals to self.dx negative. So self.dx is equal to negative self.dx. And what this will do is self.x is less than or equal to 0, which is the left, or greater than or equal to 0 is 400. And the reason why we do greater than is because our frame is updating every 30 frames per second. However, depending on how fast your ball's moving, it might actually miss the 0. And if it does that, then it won't ever do anything, right? Games aren't perfect. There's lag. There's stuff updates and then you missed it. So it's very important that in these scenarios you do greater than or less than, because if the ball was here and then on the next update it was here, well, it's past 0 and it wouldn't do anything. So that's why we do less than or equal to. But now if we play it, our ball is going to bounce off all of the walls. Awesome. Now we will eventually delete this. So I'm actually going to leave it as magic numbers because one, I'll see it better because we shouldn't be using magic numbers. And two, I wrote temporary because we're going to delete it later. But last but not least, we need to get rid of our magic numbers. We do not want 0 and we do not want 240. Maybe we change it. Maybe we make a power up where the ball bounces sooner. Who knows, right? So what we want to do is we want to hard code again this information so that we can edit it later. So we'll call this boundary top equals 0 and self.boundary bottom equals 240. This way, if we ever need to change it, we can. And two, it's easier to read. We know exactly what 0 and 240 means. They are self.boundary top and our self.boundary bottom. Awesome. And if we save and reload, it now works the same. And then let's say we wanted our ball for some reason to be half the size. We could do 240, and now it bounces somewhere in the middle, which doesn't make sense, but now we can easily code that. All right, well, that's pretty much it for our ball. We've created a ball and it's bouncing around everywhere, which is awesome. But now we want to be able to smack that ball. That didn't sound right. But we want to be able to use a paddle. So now we can start making our paddle. All right, so we're going to click our Playdate and hit space to pause it because the ball is going to bounce forever. And I don't know if it's distracting for you or not. So now what we need to do is we need to make a paddle because Pong is not Pong without a ball and a paddle. So we can go over here, go to source, new file, and we'll call this paddle.lua. And let's see if you can remember what we're going to import. If not, it's okay, but let's see what we're going to import. Like I said before, we're making a class, so we need to import corelib/object so we can write object-oriented code. We're then also pretty much always going to import corelib/graphics, and then our paddle is also going to extend our sprite class, so we need to import corelib/sprites. Hopefully all of that you remembered. And cool. We also, what do we need? A reference to our graphics. So local const, gfx const equals playdate.graphics. And this is one cool about this game, but gaming development in general is it's a lot of muscle memory. You're going to make a class for your ball. You're going to make a class for the paddle. We're going to make a class for the score and all of that stuff, right? And that's really how object-oriented code works is we just make a lot of classes and then use them when we need them. So with our paddle, we're going to do class, capital P for paddle. It's going to extend our GFX sprites. Hopefully I'm not going too fast by now. If not, I'll slow down. And then what do we need? We need an init function. So function paddle, capital P, paddle init. Awesome. And I forgot to mention this in the first one because I messed up the video and had to re-record the first part, but you'll get a little squiggle right here, and all you need to do is hit quick fix and mark paddle as defined global. I'm not sure why that doesn't happen automatically, and if you know, please let me know, and if I'm doing something wrong, also let me know, but that seems to fix it, so I'm going with that. Awesome. So now I will still show you how to do this, but in your head, you probably already know a lot of the information that we're going to make because it's very similar to our ball. So first we'll do self.width equals, our paddle width is going to be 8, self.height equals 40. The height of our paddle is going to be 40. And then of course we need a radius because we did last time. Which you might not have known, but I'm going to make my paddle round a little bit so we can pass in a smaller radius of about 4. Awesome. All right. So now we can do our image here. And I want to show you something real quick. We will do create paddle image. And we only want to create this image once. And we only want to create our ball image once as well. If it's already there, then we don't need to create it. But we'll do create paddle image once. And how we do this is just like before, we do self.image equals gfx image.new. And then we can pass in our self.width, comma, our self.height. Perfect. And then we need to create it. So gfx.pushContext. And then self.image. And then anytime we push context, what do we need to do? Pop context, right? And then inside, we are going to do gfx.fill, because I want it filled, round ret. Hopefully I'm not going too fast, but by now you should hopefully have this information in your head, and if not, that's okay. But self.width, you will soon, because we'll be doing it often. Self.height, right? It needs a height, shows it right here. And then we can do self.radius. Perfect. So again, just what we did before. And Alt-Shift-F makes it better. Cool. Now, we also need to add the image. Self.image. No, self.set image. Set our image. What image? Self.image. Cool. Now, there's a way to do an if statement here, just so we're not creating this image every time if we don't have to. Good for performance. And I'll do it with the ball as well, but I wanted to wait and explain it here. So we can actually do if what? If not self.image, which means if we have not yet created our self.image, then we can create our self.image. Just saves a step. If the image is already there, just use the image. If the image isn't there the first time we're calling it, then we can do if not self.image, then make the image. Otherwise, if we've already made this image, just use it. Again, saves us some code. And we'll do the same back on our ball. Create the ball's image only once. If enter not self.image, what do we want to do? We will make the image. Not set the image. We have to set the image either after we made the image. So make sure that's not in there. Perfect. And we'll go back to our paddle. So now we've set our image. What do we want to do? Well, we need to add it to the screen. And you know what we're going to have an issue with later. So why not just self move to? Because we know we're going to need to move it. Again, the same thing we did with our ball. And what do we need to move it to? Not a magic number, right? Self.startx equals, we'll just do 20. And then self.startY equals the middle of the screen. Again, our Y is in the very middle of our object. So middle of our object, the Y is going to be 120. And then self.startx, comma, self.startY. Does this make sense? How simple is this? It's the same thing. It's just how you do it. And then if we save and reload, what's going to happen? Absolutely nothing, because we need to go back to our main.lua file. We need to import our paddle. We then need to get a reference of our paddle. Local paddle equals paddle, capital P. And this is why we make it global, because if it wasn't global, we wouldn't be able to do this, because again, local stuff is outside of it. So we're making a local variable of paddle, but we're using the global variable. And then that way we stop using the global variable and then only use the local. And if we save and reload, we got a paddle. Oh yeah, we have a paddle. It doesn't do anything, but we do have a paddle. So let's make it do something. What do we want it to do? Well, we're going to make a function here. This is not a built-in function. We're going to make our own special function. And this is going to be function, and it's going to be linked to our paddle because we're going to need reference to ourself. And we'll do paddle, and we're just going to call it move. Perfect. And where do we want it to move? Well, we can pass in a parameter where we want it to move on our y, so we'll call it dy, right? When we call our move function, we're going to give it a direction, and that direction is going to be our dy, which we'll use. So how do we move it? Well, we already know, right? We move to. So we can do self, move to, and then we already have our start x, because we're never going to move on the x. It's always going to be the x that we started at. But now we can pass in our dy, which does not exist. Again, we're going to call this right here. We're going to use this and this. This is going to be passed in, and we're going to use it here. So now all we have to do is move it by dy. Well, how do we do that? Well, we can actually go into our main.update. We'll write it right here. Move paddle, and we can do paddle lowercase because we made a local variable of it, and now we can actually pass in with the self, the colon. We can grab the function that we moved, and then we can push in any number. And if we save this and hit play, well, that didn't work right. Our paddle did move. It moved to 4, which means our y is now at 4. That's not what we wanted, right? We wanted to be able to move by, but we don't actually need to move by. Instead, we can still use move to, but we can add a different way of handling that. So we can come back to the paddle move, and then we're going to make a local variable because we only need it inside of this function. Nothing else needs to know about this, just this function, which is why it's local. If you have a local in a function, only this function knows about it. If you have local in your file, only your file knows about it. I hope that makes sense. So we'll make a new y, and this is where it gets a little tricky because we're going to use math, but I'll do my best to make sure that I kind of explain it. So what we're going to do is we're going to say self.dy, self.y, our y, is going to be adding our dy. So we're going to take, where are we right now? Where is our y? And we're going to move to our y plus the dy. And we can now pass in our new y. And if we save and then look again, move, we're still passing in dy. Now it's just on again, it's running every frame. Every frame it's moving. It's calling it, it's taking my y, it's adding 4 and moving me there. It's taking my y, which is now my y plus 4, and adding another 4 and moving me there. And it'll continue to do that, which isn't what we really want, but it is working. So now that we have that, instead of making it move automatically, let's move with our controls, right? That's how the game works. We can move with the controls. So we can comment this out for right now. And then we're going to make a new comment here. And we'll do handle paddle movements with D-pad. We're going to do the D-pad because up, down. We'll use the crank in a moment, but I want to show this first. So how do we make our player move? Well, it's actually pretty simple. We can actually do if PD, Playdate, has a built-in function, so we can do period, has built-in information, and then we'll do button is pressed, which means if our button is pressed, which button do we want? Well, we can call pd.kButton up. So if we're pressing the up button, then what do we want to do? Well, we already know what we want to do. We want to take our paddle move by 4. And we actually want to make it negative because, again, 4 is positive, which means it'll go down. Negative 4 goes up. And now we can press up. Oh, we're moving our paddle. We're moving our paddle. That's awesome. So how do we go down? Well, going down is pretty simple. We can just hit enter else if, so we're going to, if we're pressing up, go up, else if we're pressing down, pd dot button is pressed, pd dot playdate dot k button down. What do we want to do? Well, we want to move positively, aka down. So now if we save and reload, we can move up and we can move down. It's that simple. There's no collisions yet, but we'll get there. We can move. Awesome. Boop, 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 boop. Boop, 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 boop. All right. Well, what do we want to do now? Well, first, we don't want magic numbers, right? No magic numbers. How do we get away from magic numbers? Well, there's two ways. We can either A, local player movement equals 4, and then we can pass in negative player movement and player movement. That's great. But what if we wanted to change the player movement? Well, now we have to somehow find this local variable in our update function and change it. No. What we can do then is we can do it on our paddle, right? Our paddle is going to save that information. Self dot move speed equals 4, right? Or we could just do speed. We don't need a move speed. Our speed is 4. We know, you can name it whatever you want, but I know speed is going to be my move speed, especially if I'm calling it in speed. So now we can actually just do paddle dot speed. And again, paddle dot speed. Perfect. So we're going to press up or down. We're going to move by our paddle's speed. Save and reload. Oh, forgot the negative because up goes up. So we press up, we go up, we press down, we go down. Now there's one problem here. Our paddle, just like our ball initially, can go off the screen forever, and we don't want that. So how do we fix that? Well, we want to be able to make it so that our paddle is clamped. That's a good word to use. Clamped so that it can only go in here, in between our top and our bottom, right? So this is where the math gets a little trickier. We're going to use math.min. So what we can do here is we can control X to cut that. Math.min, which simply says, give me two variables, at least two, and I will choose whichever one is smaller. So math.min, we want to pass in our movement, our self.y plus our dy. But then we also want to pass in our max, which would be our boundary, which is 240, the bottom of the screen. So if we save this, now our new y is going to either choose whatever number is smaller. Either is 240 smaller, which is our max, or is where we're moving smaller. If it's where we're moving is smaller than 240, we're going to move. If it's not, we're going to stay at the 240. So now, well, that didn't really work. Why did that not work? Because of our y. You see, our y is the middle. So the middle of our paddle cannot go past 240. But our paddle is. So we need to offset that. So what we can do first is we can actually do self.boundary bottom, just like we did with our ball, is going to be equal to 240. So now we can get rid of our magic number because they are bad. But now what we need to do is we need to subtract half of our height. So we can just do 240 minus self.height divided by 2. And we write it this way. We could do a number, but again, we don't want numbers because if our height changes and we have a random number, it's not going to work properly, right? So now if we save and reload this and press down, our paddle will not go past our bottom boundary. And to prove this, the reason why we do self.out.2, let's say our paddle is double, right? Double would mean it would go, nope, can't go by it because I'm still taking half the height. So my y is right in the middle. So regardless of what my height is, I'm taking half of it. and subtracting that from the 240. And again, very important why you don't hard code numbers, because it's very hard to change. And if you do try to do that, it's not going to work as you expect. Now, we can still go off the top. That's not good. Well, how do we do that then? Well, we kind of do the opposite. Math.min chose the smallest number between our self.y plus dy and our boundary bottom. So we can select this, hit Control X, and now we need to choose the max number. So math.max, and we need to pass in two numbers. The first one is going to be our boundary top, which is 0. And our second one is going to be what we just did. So it's going to choose whichever number is highest between 0 and what we were doing, right? Hope that makes sense. If not, ChatGPT will help you. Or leave a comment, but I encourage you to use ChatGPT. It definitely can really explain stuff, but hopefully that makes sense. Max chooses the number that's the highest. Min chooses the number that's the smallest. We either want to choose where we're moving to or our boundary. If where we're moving is bigger than our boundary, we want our boundary. We're doing the opposite with math.max. Math.max is choosing the highest number. We either want it to be, which again, when you're moving up, it's negative, right? So we're either going to be a positive 0, which means we're somewhere here, or we're going to be negative 0, which means 0 is the highest number. Hopefully that makes sense. And then, of course, if we save and reload, we have the same problem because it's based on our y. So again, we don't want to pass in our top boundary, 0. We want to actually make a boundary. We'll call it boundary top equals 0. And then we do the same thing, but opposite. So we're going to add, because less than is negative, we're going to add our height divided by 2. And then instead of 0, which we would have no idea what that means in the future, we can do boundary top. Save and reload. I can also go up to these little 3 dots, view, word wrap, Alt-Z. There we go. And now our paddle moves, boink. Our paddle moves, boink. It can never go out of bounds, no matter how big it is. Let's make our height 80. No matter how big it is, it's always going to work. And this is very important because, again, let's say you added a power-up, which I don't think we're going to do. This is simple Pong. But if we added a power-up, our paddle might grow in size, and then it would have been cut off if we hard-coded that stuff, which is why you don't want to do that. Awesome. So now our paddle is moving. Let's use the crank. The crank is awesome. That's the best thing about the Playdate is it has a crank. So how do we use the crank? Well, that's pretty simple as well because there's built-in features. We can get rid of the player movement because we don't need it. We can comment here, handle paddle movements with crank. Awesome. So how do we move it with the crank? Well, the first thing we want to do is we want to check to see if the crank is docked. Docked for the crank means that you've put it away. And then if you haven't put it away, then I assume that you want to use the crank and not the arrow keys. So we will disable the movement with the arrow keys and we will let you use the crank. So first we need to check to see if it's docked. So we can do if Playdate PD is crank docked. Look at that. Built in, we don't need to do any guesswork, is equal to false. So is it docked, true or false? If it's false, then we want to do something. What do we want to do? Well, we can get the crank change. So we can do local crank change is equal to PD get crank change. Just again, I love Playdate development. It just makes sense. And then we can also add in a sensitivity. So we'll do local sensitivity. This way you can alter how fast it moves based on how little you move the crank. And then what do? Well, we just pass in our paddle move, paddle move, and then we just do crank change times sensitivity. And it gives us the same result. So if the crank is docked, if it's docked, we want to check if it's not docked. So we can do if is crank docked is equal to false. Then we're going to get the crank change. We're going to get the sensitivity that we created. We're then going to move our crank change by sensitivity. And if we play, we can use arrows because we are docked. And then if we use it, now we can use the crank. Awesome. However, we can still use the paddles. Even though I checked to see if it was docked, we can still use the paddles, which I don't use the arrows, which I don't want to do. So how do we stop that? Well, we can just add an else. So if is crank docked is false. If it's not docked, then we're going to use the crank. Else, or otherwise, we're going to handle the player movement with the D-pad. And then we can actually get rid of these because we don't need them. Clean up our code a little bit. And then save. And now we can move our... Oh, we can't move. Why can't we move? Because my crank isn't docked. Let me dock my crank. And then I can use... That just sounds so weird. And then we can use the up and down. Awesome. We now have a paddle that can move up and down. And we can use the crank if we want. Because why would you get the Playdate without using the crank? That's awesome. And we're almost there. Next we have to do is add collision so we can finally stop this ball from bouncing. All right, here we are. We are going to add some collision. That's right. Let's jump into our ball.lua file because we're going to add some collisions to our ball. Don't worry, collision's very simple with the Playdate. Most of the stuff is built in, which we can use. So let's kind of clean up our code a little bit. We'll come right here. We can do add hitbox. In order to add collision, we need to add a collision box around our object. And just to make it, we're going to comment out our move by right now just so I can get the ball to stop moving. Perfect. So we're going to add a hitbox on our ball. And we can do this by doing self and then call set collide rect, which is a built-in function. And then with the set collide rect, we need to pass in some information. And as you can see, it's not telling us what that information is, and that's okay. So first we need to do an offset. Our offset for right now, we're going to do 0, 0 because we're not sure what we want it to be. And then we need to pass in a width of our object. So we could do self.width. And then we need to pass in a height. And we can do the height, self.height. So that's all we need for a collide rect, a starting position and an ending position. We're going to start at 0, 0 on the top left, and we're going to go the width of our image and then the height of our image. And if we save and reload, we can now go up to View, Show Sprite Collisions, and you'll see a little pink box right here. And this is our collision. Now, our ball is a ball and not a square, but our collision is a square in the game, which is great. But the collision is a square. However, we want to offset this a little bit so that way it's kind of just, if we turn this off for a moment, I'll try to make this bigger for you, but my ball kind of looks like a square here, right? Little squares here, but not on the end. So just to make it a little bit nicer, we're going to offset this a little bit. So with our 0, what are we going to offset it? Well, we just need to push it over 1, right? Because I just want it 1 pixel over, so we can make it 1. And if we save this, it's now push the X over 1. But I also want to push the Y over 1, down 1, so we can make this 1 as well. Great. Now, as you can see, we're starting at 1, 1, which is where I wanted to start. 1 from the top, 1 from the left. 1 on the X, 1 on the right, on the top. Obviously, magic numbers. So what do? Well, we don't want that. So we can do self.call for collision offset equals 1. And then we can pass in our self.call offset on our X. And for us, they're the same. So we can do self.call offset. If they were different, we would make 1 for the X and 1 for the Y. Awesome. Now we want to pass in our width. And if you see on our width is the width of our ball, but now that's not right because we're going over 1. Our width needs to be subtracted, right? So what we can do here is we can subtract it by what? 2. Why 2? Well, we're pushing it over 1. And we're subtracting the bottom right from 1 as well. So it needs to be -2. And we can do that on our width and our height. Control Shift F, Alt Z for word wrap. There we go. And there you go. We now have our collision right where we want, just in the middle of our ball, kind of where our ball looks like a square. But what is this? This is a magic number. We don't want magic numbers, right? So instead, we can do minus self.call offset, but we need it to be twice whatever our offset is, so we can times 2, right? And then we can do the same here, self.offset times 2. And here's where 2 is a magic number. Now, I'm okay with this being a magic number because it's double. You might not be. You might want to make a variable called double, and that might be okay. For me, I'm going to leave it, but it might be better practice to not leave it. That's up to you to decide on how you code. But we're going to just leave it times 2. Unless it bites us in the butt later, then we'll come back and change it and make it a variable. But I think times 2 will always be the outcome. And just to prove it's always the outcome, let's say I change my width by 10 and 10 for the ball to make it bigger. Now my collision is not where I want, so I need to change the collision by 10. There we go. And of course, the radius is 100 as well. If we save and reload it, we can kind of get there. 100. Is 100 what we want? 100's way too big. We want, didn't do this in testing. We'll just choose a random number. But as you can see, it does it from all 4 sides. So I think having the collision, the call offset just by 2 should always work how we want it to based on our design. Awesome. So now we have the ball collision. That's great, right? Let's go back to letting our ball move freely, and let's hit it with our paddle. Our ball's got collision. Oh, I'm docked. Our ball's got, oh, I keep trying to use my WS. Go up to controls, WASD, if you want to use WASD instead of the, what's it called? There we go. Oh, it's not letting me. That's interesting. There we go. It wasn't working for a moment. WASD can move it. And then what happened? Our paddle didn't stop the ball, but our ball has collision. Our ball has collision, but our paddle doesn't. So let's go ahead and add some collisions to our paddle. Let's go to paddle. Let's kind of clean this up a little bit because, again, I'm very bad at leaving comments. That is one thing I never really use comments unless I really, really need to know. But we'll do add paddle to screen and position. I apologize. Hopefully you're better at leaving comments than I am. And then we can, we'll do it right here. So what do? We know what we do, right? We can do self, collide, set, collide, ret. And we need to pass in a few pieces of information. What do we need? Well, we need 0, 0 for right now. Self.width, self.height. Save it, and we reload. And there we go. I'm going to pause, hit space to pause my game. Now we have the collision on our paddle. But just like our ball, I want to add some offset to our paddle. I don't like it the full size, especially because if you look at my paddle, it's actually, oh, I paused the game. That doesn't let me turn them off. As you can see, my paddle is rounded, so obviously I don't want it like that. But also for the paddle, I don't want my collision the whole paddle, right? The only part that actually hits the ball is going to be the front part of my paddle. So how do we make that collision, right? How would we make the collision for that? So what we can do here is we're going to, well, we know we need an offset. So we can do self dot call offset. And for our paddle, it's going to be a little bit different. It's going to be different on the Y and the X. So we're actually going to call it call X offset. And equal, we'll do 1 for right now. And then self call X Y offset for our Y. And we'll make that equal to 1 as well. So if we save and reload this, now we can start passing in these offsets. Well, we want it to be offset on the X. So we can do that. Self dot call X offset. If we save and reload it, okay, we moved over a little bit how we want because we don't want it right on the edge. We want it kind of in one. However, that's not what we want in this scenario. In this scenario, we kind of want to switch it around because we want it to be the width. We want it to start right here. So what we can do is we can actually take our self dot width minus our offset, right? And if we do that, now it's starting over here. It's starting in front of our paddle because we want our collision to just be that 1 pixel on the front of our paddle. So what we do is we have our offset, which is 1, because we want it 1 pixel on our X. But then we need to start, rather than at the top left, we need to start at the end of our paddle on the X, which is our width. So we're going to start at the end of our paddle, and then we're going to subtract 1 to come back 1 pixel. Awesome. Now on our Y, what do we want on our Y? Well, our Y is actually pretty self-explanatory. We just want it to start, call Y offset. We just want it to be offset by our Y. And we want to bring it down. I don't know if it's kind of hard for you to see it, but we want it to start right here. And we actually come down 2 pixels for that. So we can actually make our Y offset 2. If we save and reload, it's just right where that paddle connects, right? Outside of the roundedness, we want it right here. Awesome. Now, what do we want the width to be? Well, we actually want the width to be whatever our offset is. So instead of self.width, we want self.offset collision X offset. If we save and reload this, now we're just right there. We're right there. We're only going 1 pixel back and 1 pixel over, so we're right on the edge of our paddle. And then with our height, what do we want for our height? Well, that's kind of the same as before. We want to take our height minus our self call Y offset, which is 2, and then we want to multiply that by 2. Alt-Shift-F to make it nicer. Perfect. And there we go. We now have the collision on our paddle just right here. Now we can block our ball, right? We can go and, oh, what? My ball has collision. My paddle has collision. Why are you not colliding? Well, it is. But we don't know that because we're not doing anything when we collide. So let's do that. We can go back to our ball.lua. And now we need to add in our ball's collision. What do we do when we actually collide with something, right? So we can come down here and we'll add a comment. Handle paddle collision. Perfect. Collisions, I guess. And how do we do this? Well, there's a built-in function to get everything that we collide with. So we can do local paddle. And we're only going to be able to paddle with, collide with a paddle, which is why it's called paddle collision. There's only ever going to be 1 ball and 2 paddles. So if you hit something, it's a paddle. If there was something else in your game, like power-ups or all of that, then you might have to tweak this code a little bit. But right now, we'll just do local paddle collision. Because if we hit anything, it's going to be a paddle. So for a paddle collision, we need to get a reference to anything that's overlapping our collision. And we can do that by doing paddle collision equals self, which is our ball. And we can check the overlapping sprites. Our overlapping sprites is a function, so you need to make sure you add the parentheses. And then this is going to give us a reference to all of the sprites that are overlapping our collision. However, we only need the first one because it's going to be the paddle. If we overlap something, it's our paddle. Let's just pretend it's our paddle. It is our paddle. We're good to go. So we can do bracket and then pass in 1. We're only going to grab the first one. That's going to be our paddle collision. Now we can check if there is a paddle collision. So we can do if paddle collision. And without writing equals true or anything like that, if there's a paddle collision, if something exists, then we have the paddle collision. So what do we want to do with the paddle collision? Well, it's actually pretty simple. We did it before, bouncing off the walls. We can just do invert X direction after hitting the paddle, right? That's all we want to do. We just want to switch our x. So we can do that by self.dx equals negative self.dx. And if we save this and reload it, and we play our game, and the ball is coming, and we blocked the ball. We blocked the ball. And now we have a fun game of squash. Video's over. Just kidding. But we have a ball that we can stop. And let's turn off the collisions because now you see how they're working. We can just sit here and play squash. Awesome. I'm going to play it a little bit longer because this game is fun. And it's not even a lot to it yet. It gets even better because I finished this game, which you'll see in another video. But this is it. We have collisions. Awesome. We're playing squash. We're almost there. We just need one more paddle. All right. So how do we add another paddle? Well, adding another paddle is actually pretty easy. We already know how to do that. Right here, we can go back to our main.lua file. We can do local. We'll call this one opponent equals and then paddle. Perfect. And now we can save. And if we move, there's two paddles. There's two paddles. That's awesome. Now our one paddle can't move, but there's two. So how do we get our paddle not on our left side, but on our right side? And then two, how do we add movement to our opponent so that we can actually versus them? So let's do that. Well, first, what we need to do is we can pause our game. We need to go into our paddle.lua and we need to think about how would we get the second paddle to a different location. Well, with our paddle in it, we can actually pass in different information. And one of the information we could make up is a type. So we can do type. So we're going to need to pass this in. So if we have our paddle is a paddle, but for our opponent, we want a paddle, but we want our opponent paddle. So we can actually pass in a type opponent. If we pass in a type, great. If we don't pass in a type, as long as we set it up properly, then we don't need to, and it'll just default to the normal stuff. But for our opponent, we're going to pass in opponent. And now we need to use type. Well, how do we use type? More importantly, what do we want our type to change? Well, we want our type to change our start X, right? Our start X right now is 20, but our opponent should be like 380, right? So we can come to start X and we can actually add in, we can check our type with an ternary function. And we can do this by writing start X equals type equals opponent, right? We're going to hard code opponent because that's what we're looking for. And this is essentially an if statement. If type is equal to opponent, and then we can write and, which is a little weird in Lua, but I understand it. But and what? So if type is equal to opponent, then, we're going to say then instead of and, then we want our start X to be 380. Otherwise, we want it to be 20, right? So if type is equal to opponent and 380 or 20. So if it's an opponent, this is true. We want it to go to 380. This is false. We want it to go to 20. And we're doing it this way because we're going to pass in type. If we pass in type opponent, then it's going to be true. If we don't pass in type, well, then it's not opponent, so it's going to be false. And this is our way of getting around not being able to pass it, which is cool. And if we save this and we just reload, boom. We now have a paddle. Did you see that glitch? We'll come back to that in a moment. It's not a bug, it's a feature. But we now have our paddle on the left and our opponent on the right. And we can move. Our opponent cannot, but we can move. And we could, we just won. Good job, right? Now, there's one issue. Our collision for our opponent is the same as the collision for our player, and we need it flipped. We don't want that, right? We need him to be on this side. Well, we could flip our opponent potentially, but that we don't need to do. So how do we do this? Well, we just need to make a new collide rect. And we can do this by checking first if our type is opponent. So I'll add a comment here because I normally forget. Check if opponent change collide rect. Right? And we want to do it after the first one. We're going to always add this collide rect. But then if it's our component, if it's our opponent, we're going to change the collide rect we just made to the opponent's collide rect. So we can do if, hit enter, type is equal to, that's not how you type is equal to opponent, just like we did up top. Then what do we want to do? Well, we just want to make a new self collide rect, and we can actually just copy the one we already have to get a baseline, and we can save it. Okay, cool. Now, how do we want this to be for our opponent? We want him on the left side. So instead of our width minus our offset, we want it to start on the left on our X, so we can just type in 0. Again, I'm okay with 0. I know what 0 always means, potentially. At least current me does. We can still keep the self.call y offset. We can still keep this because it's doing the same, and that's all we had to change was just make it 0. And now that we've made it 0, the collision is now on the left of our opponent, but on the right of our paddle. Awesome. So now it's working like it needs to. And that's all we have to do to be able to add the opponent and change his collision. But now let's make it so that he can actually move just like we can, but with AI. Which isn't really AI, but it is AI. He's a robot. So how do we do that? Well, we can go back to our main.lua file, and right below where we handle the movement with the player, we can start adding the movement with our AI. However, our update function is getting a little messy. We have a lot of stuff in here, and we're about to add more. It's kind of best practice to separate our functions into functions, and we can do that by making new functions. So we'll come right below where we import our locals, and we'll actually make a new function, and then this function is going to be local because we only need it to be referenced inside of this file. So we'll do function, and what are we going to call it? Well, the first one is we can do player control crank, and we can pass in all of our crank logic just to make it a little bit easier to read. So we can hit Control X and paste it in. And then we can just call our function here. So we will do, if it's not docked, we can just do player control crank. And that's going to call the same code. And we can test that by using the crank. Now we can make another one, local function. And then this one will be player control d-pad. And it's best practice to make these, is it camel case? I think it's camel case. The first one is lowercase, every other word is capital. And then we can just pass in all of this. Control X, paste it, and then player control d-pad. And then we can hit Alt Shift F and make sure we have the parentheses. Perfect. So now, as you can see, we can still do it this way. We can dock it, still do it this way, but this is much cleaner, right? Handle paddle movement with crank or D-pad. D-pad. Perfect. And then we can also comment this as well, because I always forget. This function, we'll just call it handle player control with crank. And then this one is handle player control with D-pad. Perfect. And then handle with crank or D-pad. Great. Now we can do one for our AI. So we can actually know that we're going to clean it up. We can just do handle AI opponent movement. And we can make a local function. Local function. And we will call this AI movement. Awesome. And then we can call it here AI movement. And then nothing really changes. But now we can start coding in what we want to happen. what do we want to happen? Well, first what we need to do is we want to move the ball move the opponent towards the ball's Y. So we can actually comment that. Move opponent towards the ball's Y position, right? Well, now we need to get a reference to our Y, and we already can do that because we have our ball up here. So we can do local ball Y equals ball.y. And then we need to get a reference of our Y, which we can easily do. Local opponent Y equals opponent.y. And again, we're referencing opponent. And now what we want to do is we want to move our opponent. So we can do opponent move to, lowercase, move to, and then where do we want it to move to? Now, as you can see here, we are not using the default move that we have with the paddle. We could, but then we're going to have to change this code a lot, which we don't necessarily have to do. This is pretty simple in here, but we could. But instead, we're going to kind of reference that a little bit and use it. Well, we want to move on our X. We don't. So we can pass in our opponent.x. We do, however, want to move to our Y. And what Y do we want? Well, first, we can just grab our ball Y and see what happens. All right. Our opponent is always moving to wherever the Y of our ball is. So wherever our ball is, our opponent is moving there, which is great. However, this is impossible to beat. And for a fact, if we switch back to our ball and we change our dx to say 8 and our dy to 8 to make it faster, you can see our AI is unbeatable because it's always going to move exactly where the ball is every time, no matter what. And this is hard mode. If you want to practice, sure, have a guy that's unbeatable. But then in that scenario, why not just go up against the wall? But we don't want this. We want him to be good, but not perfect. And we can do that by changing him around a little bit. We need to add in other information so that he is not perfect. And this is getting a little bit tricky, so I'll try my best to explain it. But what we want to do first is we want to, let's see here, we'll calculate the difference between our Y and the ball's Y because we don't want it to be perfect. We want to know what the difference is that we can move him to. We don't want to move him directly to the ball's Y. We want him to move to where the ball Y was compared to we were and move that way. And we can do that by doing local diff Y for different Y equals our ball Y minus our opponent Y. So take where our ball is, subtract where we are, and what's that difference? That's where we want to move to. And if we pass this in, well, that's not good, right? That's not what we want. So we need to take this information, but we need to change it around as well. So we can make a new Y like we did before. Local new Y. Let me pause this for now. Local new Y. What do we want it to be? Well, we want our new Y to be our current Y plus something, right? We want to add to it. What can we add to it? Well, we can add to it our difference Y. Let's see what happens there. Okay, we get the same experience. Well, that's because we're doing the ball Y. Let's pass in new Y. We still get the same experience. However, our opponent is not perfect anymore. Our opponent is no longer following the ball Y. he's taking where he's at and where he should be. And with this, we can actually test this by increasing the ball speed back to 8. If we save and reload this, our ball is still perfect. But I thought we altered it. I thought we made it different. We did, but not enough. Because it's still semi-perfect, because he's still taking where he is and where he needs to be, and he still goes there, and he goes there super fast that he can still go there in time. So how do we change that? Well, what we need to do is kind of add in some type of speed or some type of delay, whatever like that, so that he's not moving perfect. So let's do that. How can we do that? Well, what we can do here is we can switch it out with a math.min, so we can choose different information. So we can do math.min, and we want to choose the smallest number between different things. So what can we do? Well, first we can pass in the speed, which we don't have. So let's make a speed for our opponent. So local speed equals, we'll just say 6. So math.min speed, and then we want to pass in diff y. Right? So we're going to choose whichever number smaller, the speed or the difference. And if we save and reload this, let's see what happens. Wait a minute. We're on to something. Our ball isn't perfect. Our ball cannot keep up with it because he's going to be moving by a speed or by the difference y. Which means sometimes he's going to be moving at 6. Sometimes he's going to be moving at whatever this number is. And because of that, he can only do the smallest number. He's going to get behind. Awesome. But it's not perfect. I mean, it kind of is perfect. It looks perfect. But we can also do a little bit, because if you see right here, a few things. One is he's not moving proper. He's kind of like speeding up and slowing down, speeding up and slowing down. So we need to make that more smooth. So let's do that. Well, we can add in, we'll comment here, we'll do AI smoothing and delay. The delay is the speed, and we're about to add smoothing. So we can do smoothing factor, and you can mess around with this, but we'll do 0.5. And now we need to apply the smoothing factor to our diff.y. So we can do times smoothing factor. And if we save and reload this, now he's normally gradually always going, right? Other than when he goes up, he kind of feels like he goes up faster, but he goes down more smoothly, right? And of course he needs to go faster because the ball is going up faster. Awesome. But we need a little bit more math here, because we need to make sure that we're choosing the right variables. And this is a little bit harder to explain, so let me just write it. We're going to do math.max, and we can pass in our negative speed or the diff y with the smoothing factor. So what this is saying is we're going to take our opponent's y. We're going to add to it the minimum between our speed, which is 6, or the maximum number between negative speed and our diff y times smoothing factor. So if our diff y times smoothing factor is bigger than negative 6, we're going to use that. Otherwise, we're going to use negative 6, in this case, our speed. And then once we know which one is bigger, we're then going to take the minimum from our speed or negative speed. So which one is smaller? 6 or negative 6? Or 6 or whatever this became, right? And that's going to help out a little bit with our y. And as you can see now, our ball is able to still keep up pretty well, but sometimes he messes up. Perfect. We can watch it again. He's hitting it, and now he can't. Now, if we lower our ball speed, because 8 is pretty fast, we can save it. And now we can kind of see a little bit better what's happening. He's following along. He's smoothly going there. He's doing good. He's doing good. We can factor in as well. I missed it, but we can factor in it well. And as you can see, he's still hitting pretty well. He's still hitting pretty well. But there's one slight issue here. If you look at our paddle, it's going into the top and bottom, which we don't want. We can't do that. Why is our opponent allowed to do that, right? So we need to make sure that we clamp essentially where he can move. And we can do this pretty easy because we already know how to do that. So instead of new y, we can do math.min, and we're going to get our opponent, which is in our paddle class, boundary bottom. So we're going to choose between the minimum boundary or math.max. We're going to choose between the top opponent dot boundary top. Boundary top. Or our new y. So again, just to read this, because I know this gets a little tricky, we're going to choose the maximum number of either our boundary top, which is 0, or our new y, whichever number is bigger. And then we're going to take the minimum from our boundary bottom, which is 240, or wherever we should be. We're going to take the smaller number. And if we save and reload this, we now have our paddle getting stuck, right? And where he was kind of perfect, now he can't be super perfect because he's going to not be able to follow the y outside of the bounds. Awesome. Now he's still perfect. As you can see here, I cannot beat him with a slow ball. And that's why we're going to increase our ball so that we can actually beat him. Because on his speed is 6, our ball is 4, he's always going to win. He can always get there. But when we increase our ball speed after each time him and I go back, the ball is going to get faster and faster. He's going to not be able to keep up with it. So let's do that. All right, so now we need to make it so that every time we successfully hit our ball, it continues to increase in speed, so that way eventually we can be faster than the opponent, and then if he messes up, we can win. But if we mess up, then he wins. So how do we do that? Well, we can go ahead and pause our game, and we can go into our ball.lua, and we can change around our collision a little bit. And our collision is going to get a little messy. So what we can do is we can actually hit Control X on this, the handle paddle collisions. We can hit Control X, and then we can make a new function. And in this one, we need a reference to ourself. So we're going to actually pass it with our class name. So ball, handle, paddle, collisions. Perfect. And then we can paste in our paddle collisions. And then we can just call, we'll comment it here, handle, paddle, collisions. And then we can do self, handle, paddle, collisions. Perfect. And if we save and reload this, nothing should have broken. We're still good. Cool. Well, how do we make our ball get faster over time? Well, it's really simple. Once we have a paddle collision, this means we hit our paddle. We can make some variables here that we can then use to increase our ball speed. So we can do the first one, local speed increase factor equals 1.05. This is essentially 5%. Well, we're going to take this, we're going to multiply it by something, and every time we multiply it, it's going to get 5% better, 5% more. However, there's a point where it'll get way too fast, so we need to make sure that we can clamp that, and we'll do that by doing local max speed equals 10. So we're going to increase 5% every time we get hit to a max of 10. We can no longer go past 10. Great. Now, how do we increase the ball speed? Well, we already have access to the ball speed. That's our dx and our dy. So we can do self.dx equals, and then what do we want? Well, we can do another math problem here because we want to make sure that we're clamping our speed to the max. So math.min, we always want to choose the smallest number, is going to be our self.dx times our speed increase factor. Or we're going to choose our max speed. So again, hopefully math.min and math.max makes sense now, but if it doesn't, we're going to choose whichever number is smaller, which is our self.dx times our speed increase factor, which is going to be like 4, and it's going to be 4 times 1.05, then which is 4.2, and then 4.41, and then 4.63, et cetera, until we get to the max speed. If at any point in time this number is higher than our max speed, which is 10, then we're going to always, 10 is going to be the smallest number. We're no longer going to choose this number, and we're going to just choose our max speed. And then we need to do the same with our self.dy. So we can do self.dy is self.dy times speed increase. Perfect. So now if we save and reload this and we start playing, it's kind of hard for you to tell. We could always print the numbers if you wanted to, but you'll see in a moment, because I have so much practice at Pong now since I've been making this, we're going to get a little bit faster and faster. We'll wait here. We'll get a little bit faster. All right. Hopefully you guys can tell it's getting faster. It's getting a little bit harder. I can only move so fast. Our opponent can only move so fast. It's getting closer. I missed it. That's okay. It's still going to go because we got the walls on our side. But even though earlier, there we go. Our opponent misses it. He can't keep up. He can't keep up. We're too good. We were too good. He's now struggling. And that's great. And now he continues to lose because we have the balls on our side. Awesome. But there we go. We can pause that. So now every time we successfully do it, it gets harder and harder, faster and faster, harder and harder. And then eventually it gets to 10. And then me and the robot are just battling it back and forth until anyone loses, which is awesome, which is great, which is a lot of fun. Okay, now what? Well, now what we want to do is we want to make it, now that we can actually play the game, we want to make sure that it doesn't bounce off the walls. So our temporary wall collisions can go. We can comment this out. You can keep it there for testing, but we can comment it out. Now, if we miss the ball, it's just going to go off forever, which we don't want. What do we want happen? Well, we want to be able to reset the ball. So what we can do is we want to reset the ball so we can actually make a function that does that. Function, ball, reset. Perfect. Oh, reset. There we go. And then what do we want it to reset? How do we want it to reset? Well, really, we just want to move it back to our start. So we'll do self move to self.start x, comma, self.start y, right? And now, how do we call this? Well, we want to call it when the ball goes out of bounds. And there's a few ways that we could do that. For example, we are checking the top. We could check the left and the right, and that's okay. But we can actually do this in our main.lua because this is where our game exists, right? We want our game to kind of do some of the stuff too. So we can actually check if we go out of bounds from our game's point of view. And so we can do that. We can make a new function here, right below our other AI movement. We'll do local because no one needs to really access this except for our main. And we can do handle ball out of bounds. Perfect. So, and then we want to make sure that we call our handle ball out of bounds. So handle ball out of bounds. And then how do we check that? Well, it's pretty simple. We can say if our ball.x is less than or equal to our ball.boundary left. Oh, we don't have a boundary left. We should make one. Let's go up here where we have top and bottom. We can do self.boundary left equals to 0. And self.boundary right is equal to 400, which is the left and right of our Playdate game. Cool. So now if it's less than or equal to the boundary.left, or just like we did before for the x collision, our ball.x is greater than or equal to ball.boundary right, then what do we want to do? Well, we just call ball reset. Pretty simple. So now when our opponent hits the ball and we miss the ball, oh, we got an error. What do we do wrong? Move to Playdate geometry point expected got nil. Uh-oh. What does that mean? Well, this is how you read error codes. We can actually go through and see, all right, well, the error first hit on line 64, which was handle ball out of bounds in our main.lua, which was calling line 54. Right here, our update function. Okay. And then in our ball, line 74 is where it failed. So line 74 in our ball, well, self move to, start X, start Y. Move to. Okay, well, what did I do wrong? Well, I did not capitalize start X. I do that a lot. Perfect. Now, but that's how you read error codes and narrow it down. There we go. All right, now our ball is going off screen and resetting. But now this isn't really fair. It's always going to randomly choose where it left off last. It bounces off the top. Now it's going down. It's going to go to the down, right? We want this to actually be random. So how do we do that? Well, first we can make some variables. So we will do local speed x, which is our x direction, is going to be, what do we want here? Well, what we can do is we can use a math.random, and we can pass in two numbers. We're going to choose between 1 and 2. And then what we want to do is the ternary. If it's 1, then we want to do something by writing and we want it to be 4 or 4, right? Do we want 4? Where did I get 4 from? Well, 4 is our dx and our dy, but maybe we should make our own variable for speed. So self.speed equals 4. We still want 4, but now we want to know what these 4s are. So instead, we can do speed, self.speed, and then we can do self.speed. But we need one of these to be negative, right? So we're going to say if local speed x is equal to a random number between 2, if that random number is 1, then we're going to choose self-speed. Otherwise, we're going to choose negative self-speed, which if you remember earlier, will make us go up or down. Or, well, left or right for the x. And then we'll copy this, Alt-Shift down to copy this. And then we'll do speed y, speed, same thing. But now this will make us go up or down. Perfect. Great. Now, what do we want to do? Well, we want to set our self dx and our self dy to our speed x and our speed y. So self.dx, which is our direction x, we can do speed x. And then our self.dy is equal to speed y. Again, these are local, so we don't need self. And then let's save and reload. And now opponent is great. He hits it, and now it's random. Oh, it went back to him. Great. Hits it again, and now it's random. All right, perfect. Hits again, it goes out of the screen, and now it's random again. Perfect. But we don't want it to be immediately, right? We want to add some delay in here. So how do we do that? Well, first, we need to check if we should be delayed. So let's do that. We can come down here, and we can make a new variable called self is waiting. Is our ball waiting, right? And by default, we'll make it false. All right. Now we can check to see, before we move our ball, we can hit Control X on this with our move by. We want to check to see, if ball can move, and then move. So now we can say if not self dot is waiting, meaning is waiting is false. If it's not false, then we can move. So if we save this, and then we wait for the reset, well, our ball's moving. Why? Because we're not waiting. Is waiting is false. Okay. Well, how do we make is waiting true? Well, we can do on the reset, we can just say is self dot is waiting equals true. All right. So now we're going to wait. The ball's going to hit. The ball's going to now wait forever, because there's no way for us to turn off is waiting. So how do we do that? Well, that's where timers come in. We can actually come up to the top and we can go right under Playdate Graphics. We can add a timer. But first, we need to import our library for timers. So Core Labs timer. And then we can do local timer const equals Playdate dot timer. And now we have access to using a timer. So where do we want to use the timer? Well, after self is waiting, we want to add a timer so that we can do this, right? We don't want to change the speed immediately. We want to wait. So we can do timer dot perform after delay. The delay is going to be 1,000 because this is in milliseconds. 1,000 milliseconds is a second. Then we can hit comma and then pass in a function. And then we can just take this information, paste it in, Control Alt Shift F to make it look nicer. And then we can set, after we've done that, then we can set is waiting to false. So let's see what happens. The ball should hit. The ball should go off the screen. It should wait a second, and then it should move. Why isn't it moving? We set a timer. The timer should run, and it should work. Well, anytime you need a timer, you actually have to update the timer. Timers don't update automatically. They don't know how. So we can go into our update function, and then the very last thing we're going to do is timer dot update timers. That's going to update all of the timers that our ball class is using in its update function, which then gets called in the GFX sprite update. Perfect. So now let's try it again. Our opponent's great. It's going to hit the ball. It's going to go off screen. It's going to wait a second, literally, and then it's going to move. And then the same. Awesome. Now, the only thing, though, is it doesn't do that at the beginning. It starts right away. Why? Because we set it to move to right away. Well, we don't need to move to anymore. We can just do what we want. We want it to wait a second and then move. So we can actually just do self.reset. And I like to have add at the bottom because that's the last thing we're going to do is add it to the screen. So we can do this. We're going to add ball to screen and position it with the reset first, and then we're going to add it. And now it waits for a second at the beginning as well. So goes off screen, waits a second, chooses a random direction and moves that way. Waits a second, chooses random direction and moves that way. Waits a second, chooses a random. As you can see, it just, lovely. Perfect. So what do we want to do next? Well, now that we have the ability for it to track going off the screen, let's add a score. That way, every time it goes off either the left, the opponent scores, or on the right, the player scores. So how do we do that? Well, we can make a new file called, in the source, go to new file, and we'll call this score.lua. And what are we going to do? We know what we're going to do. We're going to import our core libs / object because we're making a class. We're going to import our core libs graphics because we always need them, almost always. We're then going to grab our graphics. Hopefully you already know this and you don't even need me at this point. Playdate.graphics. And then we're going to, yep, you guessed it, make our class, lowercase class. Just testing you there. Just kidding, it mistyped. And then what is our score going to do? Well, our score is actually not going to be a sprite. It's not. It's going to just draw some graphics on the screen, and it works independently of the sprites. It doesn't need to be a sprite. It can draw itself, right? We're going to code it so it just draws itself. So we don't actually need to extend anything, but we still need a function in it. So we can do score in it and then get that little squiggly. Again, we highlight it, quick fix. Please let me know why I have to do that. And we'll make it global. So what do we need to pass in for our score? Well, that's actually pretty simple. We can do self.player score, right? Equals 0. And then self.opponent score is also going to equal 0. And then in order to draw, well, let's come back to that. Now what we want to do is we want to make a function that is going to draw the score. So we can do function score, because we're going to need reference to ourselves, draw score. And then here we can actually draw stuff. Now we are going to draw text. We're going to, let me stop the game. I'm sorry. I don't know if that's distracting or not. We're going to draw text. Anytime we draw text, we're going to want to set a font. Now we're going to use a built-in font, but you can make your own font, but that's beyond this video. I don't even know how to do that yet, technically. So we're going to use the default font. So we can just do self.font equals GFX get system font, and then we can pass in a variant, which you see right here, normal, bold, and italic. I'm just going to choose bold, which is gfx.font.k variant bold. Perfect. So now we have a font. So in our draw score, what we're going to do is we're going to set our font, gfx.set font, and then we can pass in our font, which is self.font. Now we have a font. Now what we want to do is we want to draw something to the screen. So we can do this by gfx.draw text. And I want it to be aligned because we're going to add a paddle down the middle, like a net down the middle. And I want it to be aligned on the left. I want it to be aligned on the right. On the right, I want it to be aligned on the left, just so it looks spacing out. You'll see in a moment. So we're going to do draw text aligned. And then we can pass in some information. The first thing that we need to pass in is a string. And that string is, we're going to do 0 for now. And then we need to pass in what do we need to pass in? Well, we need to pass in an X and a Y, and then an alignment. So we can do 10, 10, X 10, Y 10. And then for the alignment, we'll do K text alignment dot right, because this is going to be on the left. We want it to align on the right so that it writes the number. For example, if the number was 0, let's say 100, it would start on the left by default and make it go to the right. Whereas if we do right align, it would write it like 0, 0, 1. But it would start at this location. You'll see in a moment, but hopefully that makes sense. Now that I see trying to explain it, I might not have. All right, perfect. And now what we want to do is we want to do one more. And then this is going to be the opponent score, which will do 10. And then we want the left alignment. Cool. And if we save this and reload it, what's going to happen? Absolutely nothing. Why? You know why. Because we made a file, but we didn't use the file. We didn't call the file. So we can go back to our main.lua, import score, and then we can get a reference to the score, local score, because we have to call it, and then that's called score. Now if we save and reload, we get an error. Why do we get an error? Well, we get an error because, well, let's figure it out. Main Lua 5 in function import score. All right, what did happen? Well, we attempted to index a nil value, which is score. Because even though we made a class that's not extending anything, we still have to call it .extends and just pass in nothing. I'm not exactly sure why. If you do know, let me know, but we're gonna just say it extends, probably because it needs it for Playdate to actually do stuff properly is probably the right answer. It won't know to call the init or the update or stuff like that. So we need to just do .extends, but we don't need to pass anything. Now, obviously we made our score, but it's not drawing to the screen because we need to go back to our main.lua and we need to draw it. So right here, after the GFX sprite update, this updates all of our sprites. Now we can draw score to screen. And we have to do it after the GFX sprite updates because they will update all of the sprites and clear the screen. So then we have to wait for all of our sprites to update and then we can draw. So we can do draw score after our sprites update. And if we hit refresh, there we go. We now have our score, but the score does not work how we want it to. Let's hit spacebar. It's at the top left and we don't want it at the top left, but we did that for testing. So now that we can actually see our score, let's go ahead and move it where we want it. Well, where do we want it? Well, we want it kind of in the middle, right? We want it right in the middle. We want our player score to the left 20 pixels, and we want our opponent score to the right 20 pixels. So we could hard code that, but we already know, no, we do not want hard-coded numbers. Magic numbers are a no-no. So what we can do is we can do self.score y, which is going to be our y position. We're going to move it off the top. So we can do self.score y, copy this, and then paste it here. And then where do we want our x? Well, we want our x right in the middle. So self.score x, nope, we have different ones. So we'll do player score x equals, and we want it to be right in the middle, minus 20. So we could either write this, or we can just write 180. And then we want self.opponent score x, and this is going to be right in the middle, 20, 200, plus 20 is 220. And then we can pass these in as well. Self.player score x, and then self.opponent score x, and then we can word wrap. Perfect. And we got an error, y, and I messed up the y. There we go. Self y and self y. There we go. Typos are the death of me. So there we go. Now we have our score at the top of our screen, right in the middle. And on the left is our player score. On the right is our opponent score, which we hard coded. Well, we don't want to hard code that information, right? We have player score. So what we can do is we can pass in player score. However, if we do self.player score, we're going to get a squiggly error. And the reason why is our player score is an integer, and we need to pass in a string. So we can do that by selecting it, Control X, and then we can just do toString, which is going to take anything we give it and make it a string. And then inside we can pass our player score. And we can do the same for our opponent score. toString, pass in opponent, self.opponent score. The actual score, not the X. And now they should both be 0. Perfect. Well, now what we want to do is we just want to be able to add to our score. So we can make some functions. Function score, because we need reference to ourself. We will do increase player. And then we can just do self.player score plus equals 1. We're going to copy this and do the same for increase opponent. And then self.opponent score plus equals 1. And then mostly, we probably won't be using it right now, but we'll be using it later. We can do function score, and then we'll do reset. And then this will just add our self.player score to 0 and our self.opponent score to 0 as well. I don't know if I use it in this tutorial. I can't remember, but it is, we'll keep it at 0. If we need to make them 0, we can do so. We could always add a menu button when we hit the menu and reset score. Maybe we'll do that. Cool. We will use this later though when we make our game. Awesome. So now all we need to do is increase our score. Well, how do we do that? Well, we already keep track of when our ball goes out of bounds, right? We're right here. We are handling out of bounds. So we can increase the score that way. So we're going to call the reset, but we don't want to call the reset all the time because we need to know which way it went. And this one checks both ways. So we can just make a newer one here. And no, let's separate it. We will do if ball.x is less than or equal to ball.boundary left. Then we're going to reset and we're going to score increase player, which increases the player score. And then we can do else if ball.x is greater than or equal to ball.boundary right. Oh, I got those flip-flopped. We'll find out in a moment. Then what do we want to do? This one, we want to increase the player. And then if the ball goes to the left, we want to increase the opponent. Perfect. And then we can get rid of this first one because we had to separate these out. It was cleaner the other way, but now we're adding more. So we wanted ball reset and then ball and then score increase player. So if it goes off to the left, we're going to reset the ball and increase our opponent's score. If it goes off to the right, we're going to reset the ball and increase our player score. And now if we check that out, the opponent's going to hit the ball. We're going to miss it because we're terrible. And then, oh, the opponent got a score. Awesome. And then we're going to miss it because we're bad. And oh, opponent got the score. Awesome. Now let's go ahead and draw our net. Just because I want to see where the middle is so you can see where our stuff works. Well, we can do this in our functions. We can make a new function here. We'll scroll down and we'll just do local function. Local function. There we go. Draw net. And then with the net, we have to draw it after the GFX sprite update. So we'll just do it right here. Draw net. We'll do that last because I want it to be last. Okay, how do we draw the net? Well, this is a little tricky, so I'll kind of write it out and we'll kind of explain it. So we'll do local start X because we like to use the same name so we know what stuff is. Local start Y, this is where our net is going to start on the X and the Y. We need to figure out when our end Y is. Where are we going to end, which is at the very bottom of the screen, which is 240. We do need to get a section of our segment length. How big is our net sections going to be? Because they're going to be dashes. We'll just make it 10. And then we need local gap length. And this is going to be the length between our dashes. And then, of course, we need to know how wide our net is. And we will do net width equals 2. Hopefully that makes sense. We're essentially getting a start X and Y and end Y so we know when to stop. We're then going to get the length of our dashes and the gap between our dashes. And then we're going to set a net width of 2 so we know how wide our net is. And then here we're going to do a for loop. And this for loop is a little bit different. So it's going to be for Y equals start Y, comma end Y, comma segment length plus gap length do. So essentially we're saying Y is equal to our start Y and end Y. And we're going to continue to go over the loop until we're at our segment length plus our gap length. So the length of our dash and the gap between our next dash. What are we going to do? Well, we're going to continue to do this. We're going to gfx.setColor. We're going to set the color of our dashes to gfx.kColor black because we want it to be dark. And then we're going to do gfx fill rect because we want a rectangle that's filled. And we need to pass in an X and a Y. In fact, we need to pass in an X, a Y, a width, and a height. So we'll do the X. We know what the X is. It's our start X minus our net width divided by 2 because our width is 2 and we want to divide it by 2 so it's 1. So we can get our start X is where we're going to start minus 1 so it's kind of centered. And then we need a Y, which is our Y, which is right here. And then we need our net width, which is our width, and then our segment length, which is our length. Hopefully that makes sense. I spelled function wrong. Function, there we go. Why is this not? Oh, I deleted my end. There we go. And then hopefully this makes sense. If not, just let me know. And there we go. We now have a dashed net that's in the center. So our game is pretty much done. We can actually play, but we want to add in sound effects because having a game without sound is very quiet and very sad. So let's go ahead and, sorry, just can't stop playing the game. Let's go ahead and pause it so I can stop playing the game. All right, in order to make sounds, we're going to head to a website that's completely free and really cool to make 8-bit sounds. I will put a link to it in the description. It's sfxr.me, JSFXR, and we're going to make sounds. And this is pretty simple to make sounds. You essentially just click the button, and then you can tweak it if you want to, but I'm not really good at that. So what I do is I just hit these buttons a lot until I get the sounds that I like. We could do clicks or hits or explosions, you name it. And then once you have it, you can just hit download, and then it's going to download. So if we wanted this explosion, there we go. I already have the three that I'm going, the sounds that I'm going to use. So let's go over those. All right, so I have three sounds that I kind of went through, clicked some buttons until I liked them. I got one, I named it explosion, one for hit paddle, and one for hit dash wall. And we can select all three of these, and then we can go into our source, make a new folder called sounds, and then we can drag our sound into that folder. Make sure it's in the sounds, not your source. So we have explosion, hit paddle, hit wall. And I'm actually going to rename my explosion to round over. Perfect. Great. Now we have access to our sounds. How do we use them? Well, using your sounds is actually pretty simple. We have a ability built in with Playdate. So local sound const, in our main.lua file here, equals pd.sound, playdate.sound. It's built in. Sound is built in, which is nice. Now we just need to get a sound. So we can do local round over equals sound dot sample player dot new, because it's a new sound. And then we need to pass in our path. So we'll do sounds slash round dash over, and we need to make sure we pass in dot wave, W-A-V. Perfect. Now, in order to use our sound, all we need to do is figure out where our sound needs to go and call our sound play. And we already know it's when our ball goes out of the boundary. So we can do round over play. And then we can copy this and put it here as well. And now if we hit play, right, and then we just need to make sure we unmute our Playdate, and there we go. We got an explosion. When the ball goes off the screen, it turns into an explosion and resets. Now let's add the sound for when it hits the paddles and the walls. So we can go into our ball.lua. We need to import, make a local sound const equals playdate.sound. And then where do we want the sounds? Well, we can actually, what we're going to do is we're going to set these just to make it a little bit easier. We'll do self dot hit wall sound equals sound dot sample player dot new. Pass in our sounds folder, and then hit wall dot wav. And then we can do one more, alt shift down. And then this one is going to be hit paddle sound, and then instead of hit wall, we'll do hit paddle. Perfect. And now what we can do is we can figure out where we would, quote, hit the wall and play those sounds. So right here, we have the wall collisions, and we can do self hit wall sound play. Oh, I ended up passing it with the colon, not the not the period. So when we hit the wall, we're gonna hit wall sound is gonna play, and then we come down to where we hit our paddle, and then right here after the paddle collision, we'll do self dot hit paddle sound, and then mix those up, and then play, and now we should be good to go. We should have, let's play our game. In fact, I can make it full screen for you. All right, so let's beat our AI here. We'll do boom. And then we're going to win this time. Alt-Enter is how you get into and out of full screen. That was crazy. I didn't know how to do that. All right, we're about to win. There's no way he's beating us this time. We're too powerful. We've played too much. And we've... but I forgot to talk to you about that little glitch. So for some reason, if our ball's paddle hits the very top, let me pause this, hits the very top of our, hits the very top or the very bottom of our paddle, like perfectly. And it's very hard to do because we're only looking at that 1 pixel. But if you can get the ball to hit perfectly at the very top or the very bottom of the edge of the collision, then it's going to for some reason get sucked into the paddle. And I spent hours trying to fix this, and then eventually I just feel like it is a feature, not a bug. I feel like if you were that perfect, which I'm trying to do it now, if you were that perfect to get the paddle to hit perfectly on the bottom or the right, then you deserve to show off, and it'll just it's pretty cool. Plus it counts as each hit, I think, so it even speeds the ball up pretty fast too. But it's very hard to do, especially on full screen. It's very hard. There we go, look at that. Yeah, see, I cheated a little bit, but I think that's pretty cool. And then also, because of how we have our collision set up, I believe that if you do really, really well and the collision, the opponent hits back a lot and you hit back a lot. Oh, there we go, perfect. Yeah, I'm cheating now. But if you get to a certain speed, the ball will actually go through the paddle, causing whoever that happens to lose. And normally it's the opponent, but sometimes it's you. And I think it's again, it is a bug, but we could kind of fix that bug by just making our collision a little bit wider, but then that optimizes the other one to kind of mess up. So I kind of like it. I feel like if you're up there and you're hitting the ball really, really fast, then it's kind of like you spiked the ball, and even though he got it, it just like burned a hole through the paddle. That, sometimes bugs are just features. But we're pretty much done here. As you can see, we have a simple Pong game. Now, I did take this game and make it even more advanced. Like, I have the game completely done. Actually, this one's a little bit better because the code's a little bit cleaner than the one I made myself initially. But I wanted to kind of show you how to make this game. And the Playdate development is so much fun. Like, I didn't say it. Maybe I said it earlier. I haven't recorded the intro yet. But I made the Pong game in 3 days. Now, obviously, I used AI a lot. I used AI to help me explain things and understand things, which is why I'm a big believer that you should too. But I was able to go from never touching Lua, well, I've touched Lua a little bit, but never touching Playdate to having a Pong game in 3 days, less than 3 days. And then I even taught you how to do it. So I hope you guys enjoyed this video. Definitely subscribe if you haven't already, because we're going to do even more with this. Plus, I already have my next actual project in mind. So maybe I'll do some development videos like devlogs. But yeah, I appreciate you checking out the video today, and hopefully you learned a lot. If you have any questions, either ask AI or leave a comment below, and I'll definitely help you out because I really like Playdate development, and I want you to too, even if you don't have a Playdate. Now keep in mind, I don't know how well this game works on an actual device, so if you do have a Playdate, I do not yet, but I am saving up to get one. Definitely let me know if there's any major issues on the actual device itself once you make the game and test it on your game. But I'll stop talking now. Thank you so much for watching this video this far. I hope you have a wonderful day, and I'll see you in the next one.